A very good morning to Mr. Yo. I'm Lo Chun Ming from Materials Engineering, and my metric number is 2310-42190. Today, I'm going to present about my final report on statistical computing. So here's the first question. The first question is talking about responsible consumption and production, which is a sustainable development goal that emphasizes reducing waste and ensuring efficient use of resources in manufacturing. Statistical processes control is a quality tool that helps industry optimize their production processes towards the end, contributing to more sustainable consumption and production patterns. So with the help of ChatGPT, by using their commands produce and insert into the R, I was able to construct a control chart for machine 1, machine 2, and machine 3 with the given condition of pressure and temperature. So in this control chart, there are a number of groups: center standard deviation, LCL, UCL, which is the lower control limit and upper control limit, respectively, together with the number beyond limits and number of volatility runs. So in this control chart, there's one number of beyond limits and one number of volatility runs. So the number of beyond limits is the red color one, and the number of volatility runs is the yellow one. So the number of beyond limits for this control chart is slightly above the UCL, which means the process is not in control. Whereas for machine 2, there's no number beyond limits, which means the control chart is in control, but there are 6 number of volatility in the runs. For machine 3, there are no number beyond limits, which means the control chart is in control, while there is 4 number of volatility in the runs, which is 4 yellow dots. So the discussion that I made from these questions is the machine 1 mean length is slightly above the target specification of 50. For machine 2, the machine mean length is notably above the target specification of 50, suggesting a potential shift in the process mean. For machine 3, the machine mean length is also slightly above the target specification of 50. For the length standard deviation of products for machine 1, this indicates a relatively lower variability in the product length compared to the other machines. For machine 2, this indicates the highest variability in the product length among 3 machines, which could be a concern for maintaining a consistent quality. For machine 3, this indicates moderate variability in the product length, higher than machine 1 but lower than machine 2. The recommendations for the machine 1 is the stability seems relatively stable with lower variability. The recommendation given is continue monitoring and maintaining the current process control measures. Slight adjustments might be needed to bring the mean closer to the target. For machine 2, the stability is high variability and the mean significantly above the target. Recommendation method is investigate the causes of high variability and mean shift. Implement corrective actions such as recalibration of the machine or adjusting the process parameters. For machine 3, the stability is moderate variability with a mean slightly above the target. Recommendation given is monitor the process closely and make necessary adjustments to reduce variability and bring the mean closer to the target. So for the question 2, it's about we have to draw a process capability chart showing the length of the products for each of the 3 machines. The target specification LSL and USL is given. So first of all, we have to create the process capability chart R by following these steps. First, load the necessary libraries. Second, filter the data to include only the specified conditions. Third, calculate the process capability indices, generate the process capability charts. So the capability chart is also constructed by using the help of ChatGPT by using the command and insert into the R. So here's the process capability chart for machine 1. This is for machine 2, and this for machine 3. So the discussion that I made, based on the provided CPK values and the specified conditions, the machine 1 is capable, and the machine 3 is also capable. This is because the CPK values is higher than 1.33. For machine 2, it is not capable because the CPK value is less than 1.33. In summary, the machine 1 is capable of producing parts within the specified limits under the given conditions together with machine 3. Whereas for machine 2, it's not capable of producing parts within the specified limits under the given conditions. So for the last questions, it's about calculate the ANOVA for 3 machines resistors by using the R to perform the calculation and determine whether the factor is statistically significant. Here's the box plot of resistor versus the temperature for machine 1, for machine 2, and for machine 3. So the discussion that I made based on the ANOVA results provided, for machine 1, the only factor that's significant for machine 1 is the interaction between the pressure and temperature. Whereas for the pressure and temperature alone is not the factor that's significant for machine 1. For machine 2, none of the factors significant for machine 2. And for machine 3, same as the machine 2, there's none of the factors significant for machine 3. So in conclusion that I made for the first question, by implementing statistical process control and closely monitoring process capability, industries can optimize their production processes, reduce waste, and ensure efficient use of resources. This aligns with the goals of responsible consumption and productions, contributing to sustainable manufacturing practices. These conclusions and recommendations highlight the importance of SPC in achieving sustainable production goals and improving overall process efficiency. For the second questions, we can conclude that machine 1 demonstrates strong capability with a CPK value well above the industry standard of 1.33. This indicates that machine 1 consistently produces parts within the desired length specifications, making it a reliable choice for meeting quality requirements. For machine 2, it falls short of the desired capability threshold with a CPK value below 1.33, shows variability that results in parts frequently outside the specified length limits. If improvement efforts may be needed to bring machine 2 up to acceptable performance standards. For machine 3, it demonstrates adequate capability, meeting the industry standard with a CPK value above the 1.33. It consistently delivers parts within the specified length range, ensuring reliability in production output. So the recommendation given for machine 1 is continue to monitor and maintain its current performance to sustain high quality productions. For machine 2, implement measures to reduce variability and improve consistency in parts length to meet quality standards. Whereas for machine 3, maintain the current level of performance and consider further optimization to enhance efficiency and reduce waste. These findings highlight the importance of process capability analysis in ensuring consistent product quality and operational efficiency across the manufacturing processes. For the last question, for machine 1, the interaction between the pressure and temperature is statistically significant, indicating that both factors combined affect the resistance significantly. For machine 2 and 3, neither individual factors, the pressure or temperature, nor their interactions significantly affect the resistance. This finding suggests that for machine 1, both pressure and temperature, when considered together, significantly impact the resistance. However, for machine 2 and 3, neither factors nor their interaction shows a significant impact on the resistance. So that's all for my presentation. Thank you, Mr. Yu, for listening to my presentations, and I hope this data able to help you. And yeah, that's all for today. Thank you very much.